When you're adding and subtracting rational expressions, remember that rational just means fractional. And all you have to do is figure out common denominators, and then you get to combine all of the numerators over a single common denominator and then simplify. Well, the problem is, and this is a numeric example, sometimes you run into things that you don't know what the common denominator would be right away. So here is a strategy, okay? And I'm going to do just plain numbers because I know you know how to add and subtract fractions, but this is a good way to show you how to do it. The strategy is factor, okay? You will be factoring a good bit on these particular problems. So numerically, what that means is if you have 4 over, you might even do this. 4 is 2 times 2, minus 6 is 2 times 3. I usually, however, I don't factor the numerator until the very end because you're going to end up adding and subtracting stuff. So I usually leave the numerator alone and I just look at the denominator. And I know that 15, it could actually be factored to 5 times 3. And I know that 35 could be factored to 5 times 7. And 5, 3, and 7 are all prime numbers, and so that's completely factored on the denominator. Here's the thing. Every denominator has to have everything that every other denominator has. All right? You'll notice they currently both share a 5. You don't have to do anything with that 5 then. They already share a 5. However, notice this 3 right here. The left-hand fraction has a 3, which means you've got to find a way to give a 3 to the right-hand factor. And the way you do that is multiply by 3 over 3, because 3 over 3 is just 1. So really, you've multiplied by an uglier version of the number 1. Okay? So now the factor on the right has a 3, and so now they both have 3's. Now then, if you take a look, the factor on the right has a 7. Well, the factor on the left does not. The fix to that is exactly the same. Multiply by an ugly version of 1. You need a 7, so you multiply by 7 over 7. Okay? So now you will notice that the 7's are shared, and currently both fractions have a 3, a 5, and a 7. What does that multiply out to? We're not going to worry about that right now. Okay? So once you have common denominators, all you have to do is join them under a single common denominator. So it doesn't matter what order. I'm just going to go 3 times 5 times 7. That is the common denominator that they both share. Then you do the math. 7 times 4 is 28. Minus 6 times 3 is 18. Okay, so 28 minus 18 is equal to 10. And you still have a 3 times 5 times 7. Don't worry about it in the denominator. And I'm finished once I've gotten the I'm almost finished. Once I've got the numerators combined and it's all in a single fraction, the only thing I need to figure out is, can it be factored a little bit more? In other words, are there any ugly ones that are still stored within this expression? So I'm going to factor the first thing. 10 is 2 times 5, right? And so 2 times 5 is over that 3 times 5 times 7. And you can see, yep, there is an ugly one. 5 over 5 is 1, so it cancels. And what you end up with is 2 over 3 times 7. And once you're completely finished, if you're able, and there's nothing else that can cancel here, so once you're completely finished, you can go ahead and multiply that 3 times 7 to make it 2 over 21. That's the strategy you're going to use when adding and subtracting rational expressions. Factor it out. It's easier if you can see all the factors. Combine the top, get it all finished mathematically in the top, and then see if there's more factoring and see if there are any other ugly ones that you can cancel. Okay? And then once you're done, you're finished. So let's take a look at number 1. Number 1, and we're going to use exactly that same strategy. So we factored, we combined the top, is combined, and I'm just going to go through this one more time. We combine the top over a single common denominator. Okay. Then once we did that, we factored the top. Well, this is just the basic math. Okay. Then we factored the top. Look to see if there was any other simplification. In other words, those ugly ones that are possible, and then that's how the answer is arrived at. So number one again, number one from the you try section is this function. It is 4 over 5p minus 7 over 15p. Okay, remember, the strategy is factor the denominators. They're not the same, so I need to factor those denominators. 5p is just 5 times p, right? And minus 7 over, well, 15 is 5 times 3 times p, okay? 15p is 5 times 3 times p. So you're looking for commonalities, 5 and 5. All right, good deal. P, and that one has a p. All right, what the left-hand side one does not have is a 3. So you're going to multiply by an extremely ugly version of 1, 3 over 3. Okay, and what that's going to do to the first one is it's going to give you a common denominator for both of the rational expressions of 3 times 5 times p. I'm just going to leave that unfactored right now. Or sorry, factored and unmultiplied right now, because I need to see what math is going to happen on the top. So I do the math here. 3 times 4 is 12, minus, no math happened to the 7. And 12 minus 7 is equal to 5. And then this bottom part, 3 times 5 times p. I've done the math on the top. It's totally complete. The last thing I'm looking for is I factor if I need to. 5 is already in its prime factorization. I look for ugly ones, and 5 over 5 is in fact an ugly 1. Anytime the numerator cancels completely, it's not a 0, it's a 1 up there, okay? Nothing ever switches location in terms of numerator and denominator. So what you ended up with here on number 1 was you have a 1 in the numerator, and the only thing left in the denominator is 3p, and that's your solution.